Gary Fisher here again from the Project Production Institute, and I want to welcome you to today's webinar on earned value management. Let's get started by first introducing our panelists. Let's start with Jim Banaszak, who is with McKinsey. He's an expert partner for major projects in capital productivity and infrastructure, and a member of the firm's global energy and minerals, retail, and high-tech project delivery service lines. He advises clients on capital allocation, engineering design, procurement, contracting, and construction of large projects and project portfolios around the world. Comes to us with a wealth of knowledge. Welcome, Jim. Next is James Chu. James is the Chief Technical Officer for Strategic Project Solutions and has been leading research and development of SPS knowledge, processes, and systems to support implementation of SPS offerings since 2001. He's worked with various organizations in oil and gas, heavy industrial, civil infrastructure, aerospace and defense, and other industries around the world implementing project production management. Welcome, James. And finally, Young-Woo Kim is a full professor and P.D. Kuhn Endowed Professorship holder in the Department of Construction Management in the College of Built Environments at the University of Washington. Dr. Kim's main research includes project-based production management, lean construction, supply chain management, off-site construction, and project overhead cost management. He has more than 100 publications in international journals and conferences. Another wealth of information here, so thank you again for participating. So let's go to the next slide. Before we get started, I want to bring you up to date on a few things happening at PPI, some exciting things. We're soon to announce PPI certification courses at these three universities. It's just about ready. PPI also offers other training, public and in-house seminars. So if you're interested in this type of education and certification, please go to the PPI website, get registered, and watch for announcements as to when these courses will be offered. Also want to give a shout out to some past webinars, because this webinar is just a series of events that we've got looking at current project practices and issues or things you might want to consider going forward. So especially if you're tuning in for the first time, I highly recommend you take the time, go to the PPI website. All these are recorded and you catch what you've missed. Some really good stuff. So looking forward, our next webinar is going to handle the stage gate process. Well, I think we're going to shake things up a little bit. This should be very interesting and maybe just a little bit controversial. We'll see. So we're going to firm up the date. It'll be in March sometime. Again, you'll find that information on the PPI website when we firm things up. And of course, you'll get an invitation. All right, so let's look at getting started. Today, we're going to explore earned value management. Does it work? What are the unintended consequences? And what the heck do you do about it? We're going to start out with Jim covering the history of EVM, get us on a solid footing there, where it came from and what it was trying to accomplish. Young-Woo is going to talk about the theory versus reality and unintended consequences. And then James is going to clean up on, well, now what do I do? I'm on a project and what's recommended? We're going to have some time for Q&A. And I want to remind you all on your screen, you should see a little box you can enter your questions. Please get the questions going as we go through here so that we've got a good queue of questions to deal with when we get to that segment, and then we'll do a little wrap up at the end. Okay, so let's get the juices flowing. Go to the next slide. Take a look at that picture. Anybody ever see anything like that in your project? In fact, I don't think I've ever had a project where I didn't see this. And deal with the kind of things that you see on the right-hand side there. I started making my list of things that like this that I've experienced. Like I had about 10 pages worth of stuff. And that last one, commissioning checks fine, no system fully complete. That is one of the most frustrating things when you get to the end. Your progress measurement says, hey, I'm 95% complete, yet you don't have a single system you can start pre-coms work on. Next slide shows some more examples of this, especially like that one on the right-hand side, that inventory of material. Look at all that progress sitting on the ground, just waiting for something to do. Right? Not all progress is good progress, I've come to see. So what are the implications of this on the next slide? They're multifold. And if we go to the next slide, it kind of answers the question. Unpredictable results. This all adds up to giving you additional cost, longer durations, more cash tied up for longer durations, more claims, reduced quality, and that one about safety incidents. I want to dwell on that just a little bit because sometimes it may not be so apparent. But we really increase the safety risk when we have unplanned work. We have more work than we had planned. We have increased risk of work. So going back on those pictures, going back and doing those infill valves, pulling out temporary supports, putting in permanent supports, all is more risky than doing it right the first time. And I always say that the safest work is no work. So any work that can be eliminated is work that was done perfectly safely. Okay. So, well, why do owners use EVM? If there are all these issues with it. Let's go to the next slide. Well, yeah, it's very legitimate. You got, as a project, it's got to understand the current status of the project, where things are relative to the plan. You really need to be able to predict your cost and schedule outcomes. Are you on track or not off, on track or off track? You need to be able to compensate contractors synchronized with the progress of the work. That's very fair. And then most importantly, you got to take corrective action if the project is off track. Well, I want you to keep these objectives in mind as each one of our panelists shares some thoughts with us. So let's switch and now set the table, look back, understand the history of earned value management and where did it come from and what was it trying to do? So Jim, it's all yours.
Thanks, Gary, and thanks to PPI for inviting me to speak today. Why don't we go ahead one? I'm going to talk a little bit about where earned value management came from, the application of it, and some of the pros and cons that we've seen before I hand it over to some of my colleagues to get deeper into the theory. So let's talk a little bit about where earned value management came from. First of all, it's a derivation of cost variance analysis, and we're going to hear more about that and the theory behind that later. It was picked up by the military and the private sector around the same time and migrated into what we now know as earned value management and picked up by some of the project management professionals and modified and enhanced as a project management tool. I think the one key point I'd like to make before we move on is we are talking about project value here. So, we at McKinsey think about many different types of value. That's a discussion for another day. But in this discussion, we are totally focused on the value of the construction project itself. So how does this work? It's really a combination of looking at cost, schedule, and actual progress of the project in a combined way, such that, for its original intent, we can actually predict the cash that we have, let's say, burned on the project. This is very important for many accounting reasons, for reporting to financial professionals, for public companies to report to their shareholders. So the intent of earned value management as a cash flow management and prediction tool actually is very important and remains very important. I think where there are opportunities to improve comes on the right-hand side. So the intent of integrating cost, schedule, and actual progress to predict cash flow. Absolutely. Earned value management is perfect for that. When the project goes off track, you can easily see that depending on how we build the model itself. So it can provide an early warning signal of delays or cost escalation or other issues on the project. It can provide a forecast of where the project is going to end up. Again, as Gary mentioned, many of us, when we think of earned value, think if we're 95% complete, we're only waiting for the painter to come and paint everything. But oftentimes when we're 95% complete, that means everything is 95% complete and there's a little bit to do on every single system. So that is something that we'll talk about a lot here today. And then, once there is some deviation from the prediction, the model itself can help understand options to rebaseline or recover if that's required. So let's take a look at a curve here. Well, we move forward once. I'm going to describe this for a second, and then we're going to take a little survey and have some fun here. So on the left-hand side, this is a project example. This is a predictive budget or expected cash expenditure curve. On the left-hand side, you'll see percent of total cost. On the bottom axis, you'll see the project schedule in months. The budget is the solid line. The actual expenditure is the dashed line. So it's obvious that we are spending under our budget. So I'd like to take a little survey here. Either scan the code or click on the link in the chat and spend 30 seconds giving, just put in your first impression of what you think is happening on this project. And we'll wait about 30 seconds and then move on. Again, you can either scan the code or click on the link in the chat. Let's see what we have popping up here. Project is going well. Tells me nothing. Good one. Under budget. Project is late, behind, saving cash, slipping, going well. Let's give it a few more seconds. Excellent. Excellent. A lot of going well, under budget, saving cash. A few people are saying the project is falling behind, which is possible. And we have one saying tells me nothing, which is the interesting answer. Kristen, why don't we go ahead one? Let's take a look at this. So what actually could this mean? And I think you guys hit the nail on the head. So there's three potential interpretations, right? I think the first impression everyone has is, hey, it's under budget, things are going well, this is good. However, it could be it's actually late because the spend is lower than we expected and we're just not progressing the work. Could be that the project is over cost because it is very late and the spend is below budget, but we're spending more per activity than we expected. Or as many said, the project is below cost and potentially ahead of schedule, which could be a good thing. Really, this, the point of this is the curve tells us, it doesn't tell us all the information about the progress of this project, which is why we need the earned value curve. So if we go to the next page, now we have the full picture of how this project is progressing. So we still have our budget line, we still have our actual line, and now we have what we call our earned line. And the earned line, we'll talk about how we derived in a second, but now that we have the earned line, we can actually see that the project is over cost because the value of the work that's been completed to date, E, is less than the cost that was incurred, which is A. And both of those are less than what we expected to spend at this point in time. In addition, this project is also late because point E, as you can see, again, is below our projected earned value or budget curve. Therefore, we know we are also behind schedule. So we're actually over cost and behind schedule, which is the worst possible place for us to be. Without the picture of earned value, we, again, are somewhat flying blind. So, this shows the power of the earned value curve. Let's talk about how it's derived. If we can go to the next page. So again, the earned value curve gives us a measure of physical progress. And where does it come? It comes from actual physical quantities linked to a work breakdown structure. So first, the project's broken into its main physical section, could be building, utilities, or different parts of the project. And then each of those main sections is broken down in subcomponents, for example, foundation, steelwork, equipment, etc. A unit of measurement is then determined for each of these subsections. So for foundations, it could be cubic meters or cubic feet of concrete, or cubic yards of concrete, for example. Steel could be measured weight of steel. Equipment could be measured based on if it's set, has it been leveled, has it actually been hooked up, has it been commissioned, etc. But all of these measures are determined based on what we call contractual rules of credit. So the rules of credit can be quite sophisticated and complicated, and actually will influence how the contractor thinks about doing this work. So the fundamental point of measuring progress on a project, 100% useful, because we are measuring progress of physical quantities of work and paying the contractor based on the value of that work. However, there are points that can skew how we think about some of these actual pieces of work. So for example, in the public infrastructure space, departments of transportation do a great job breaking down physical pieces of work into their units. So tons of asphalt, cubic yards of concrete, etc. However, they also define incidentals to those units of work. So for example, structural concrete, the reinforcement bar, the formwork, and even the excavation can be incidental to a cubic yard of concrete. So therefore, if foundation is excavated, the formwork is up, and the steel is set, the contractor actually will not be paid for any of that work until the concrete is actually poured. This works in that space, but in other types of projects, each of those specific activities might be their own unit of work and might be paid by their own rules of credit. So how the rules of credit are set up related to the work breakdown structure actually can change the motivation and incentive of the contractor on how they think about the work, and sometimes cause some of the issues that we saw in the first few slides. The other thing to note is indirect costs are often, per the earned value theory, should not be included in the earned value calculation as part of the units of work, but oftentimes they are. So again, in the public infrastructure space, there often are not line items for supervision and overhead. So that I can tell you there are many conversations of folks saying, where should we layer these costs in this project? You typically see folks putting them into lump sum items like mobilization or site clearing or something like that, so they know that they will get paid. The alternative would be to peanut butter spread them across all the units, and therefore if one of the units were to go away, for example, the contractor is now out some of their overhead and supervision, which creates a cash issue for them. So Kristen, let's go ahead one more. So we talked about what earned value is great for. It's managing cash flow and predictive cash flow, and linking costs incurred to actual work, physical work that's been done. Earned value has parlayed itself into a number of other tools: schedule performance index, cost performance index, which are ratios of the lines that we saw in our earned value graph. But even those don't give a complete picture of what's happening when things go off plan. So folks have used critical path analysis, bulk quantity installations, other factors to try to measure how the work is really going relative to the overall turnover of system completion and commissioning, so that the plant or facility is actually running. None of these measures actually show the whole picture, because they don't focus on how the work physically is getting done. So they can highlight when we're off track. They can highlight how far we're off track. They can highlight how things might end if we don't intervene, but they actually don't provide detailed information about the root causes of why things are varying from our plan. So with that, hope this introduction was helpful. I'll turn it back to Gary, and we'll get deeper into the theory.
Yeah, that was very good, Jim. Thank you very much. Just a quick note to the audience here. We really want your questions on this. Hopefully we can stir the pot a little bit. So the chat function is disabled, the Q&A, so you got to put your questions in the Q&A box there. So just as a reminder, if you got a thought, jot it down to us. We're all ears here. So let's move on and talk about how the theory matches reality. So I'll turn it over to you, Yongwoo.
Thank you, Gary. Hi, I'm Yong Kim at University of Washington. I'm also a researcher in lean construction and supply chain management. Today, I'll address the issue of own value method from the perspective of workflow and value. Own value method has been popularly used in decades to measure the progress and cost performance simultaneously in our industry. The next slide, Christine. Thank you. And as you see in the previous slides on Jim's presentation, the both schedule performance and cost performance are highly dependent on EV, on the value. So the trade planner or the controller wants to increase on value. The on value is the budgeted cost for work completed. Since the unit budget is already fixed, you need to maximize quantity of work completed to make my trade or my project look good in terms of cost and schedule. So my first question here is, does on value method give credit to real value? This question also seeks for the meaning of value. As you know, on value method gives credit to all the works a contractor has done. So the value here should be assessed in two different dimensions, the time and the hands-on, the quantity or quality. So if you're aware of the Toyota's waste, and you should be familiar with overproduction as a type of waste. It's more than just waste, and overproduction is referred to as source of waste leading to other waste such as waiting or inventory. As you know, the waste of overproduction occurs either when you deliver earlier than needed or when you deliver more than you need. So as you see the figure in this slide, what you want to see is the deliverable of trade 1 is instantly used by trade 2. In this scenario, there is no or minimum waste or inventory. Work flows smoothly and value is generated and transferred. On the other hand, the figure below is more realistic. The trade 1 wants to produce as fast as possible or produce as much as possible, regardless of whether trade 2 is ready to work on. If on-value method metric is used to measure the performance of each trade, the trade 1 is more likely to produce as fast as possible or produce more. So next slide, please. So they are interpreted as waste because it's from the customer's perspective, the trade next to you in your production system. In this regard, we can say the value is created when customer's need is delivered when a customer needs it. To summarize, on-value method gives credit regardless of whether value is created, contrary to the name of the method. So probably the on-value method measures the producer's own value, not customer's own value. Next slide. Okay. So part of these reasons for this drawback is rooted in the theoretical assumption of on-value method, a kind of the cost variance analysis in the managerial accounting domain. The origin of cost variance analysis is found in textile production industry when they wanted to evaluate the performance of outsourcing partners. In 1920s, America enjoyed the growth of industry till the Great Recession in 1930s. As the business grows and gets complicated, the managerial accounting system also advances. Part of advancement include the concept of standard cost and cost variance analysis on each department. As an accounting theory, the cost variance analysis assumes each object or comparison target is independent. If my cost or schedule variance shows negative, my performance can be red flagged, assuming my performance is not negatively impacted by others. However, if my performance is impacted by my neighbor's performance or my upstream stakeholders' performance, then it's totally different story. When cost variance analysis was first used, a comparison target was department. Each department performance is relatively independent. However, if on-value method is applied to operation level, like a daily task level, calculating on-value or PB, prism plan value on detailed scheduled activities, we are applying on-value method to objects which are highly interdependent. So that is a place where cost variance analysis, such as on-value method, is not valid. So in my past case studies, I heard many stories that the schedulers put priority on activities with high budget in determining workflow when their performance is evaluated based on value metric. To summarize, a scheduling process designs production system or workflow. An on-value method gives more credit to tasks with high budget because it gives more on-value. For the same reason, workflow can be disrupted when on-value method is applied to operation level in that scheduler gives priority to activities with high budget. As you know, the production system design at operation level contributes to improving workflow reliability. On the other hand, on-value method needs to be used and applied at system level, not operation level. Next slide, please. And in this slide, I made up two different scenarios and two different cases as unintended consequences of on-value method. The first one is the case where a scheduler put on-value a metric priority, and the trades on field stick to their schedule. The second scenario is the case where the scheduler put the system reliability or workflow of priority in his schedule. However, in the second scenario, the flow line manager of the trade asks his trade to work on tasks with high budget first to make his trade look good in EVM metric. In the first scenario, although the trade follow their schedule, the work can be interrupted as inventory increases, inventory between trades. The data may show high reliability because the plan was executed as planned, and probably short-term on-value gains. However, in the long run, project may have problem because of the interruption and inventory increases. In the second scenario, although the schedule is well designed, the execution was not done correctly and planned because the trade worked first on the high budgeted task. So low reliability, but probably they may gain short-term EVM wins because they worked first on high budgeted task. However, in the long run, the project may have problems. So these are the unintended consequences when on-value method is applied at operation level. So I want to hand over the mic to Gary.
All right. Wow. That's a lot of really good food for thought there. Thank you very much. So go to the next slide. Given what we've heard, what can be done? What can be done about it? And James is going to carry us through some really good thinking about what do I do? All yours, James.
All right, thank you, Gary. So let's move on to the next slide, Kristen. So to ensure we actually have a solid footing to talk about what we can actually do about what we can do to minimize unintended consequences, we're going to actually refer to the standards for earned value management published by PMI. So one of the things that it actually states is without reliable inputs of planned value, actual cost and earned value, EVM is unlikely to succeed. So it seems like an obvious statement, but what it does is actually allows us to focus on some key things that we need to actually watch out for. Next, please. So how do we define what a reliable planned value, actual cost, and earned value is? Because those are the three elements that form the basis of earned value method and all the metric that Jim actually already talked about. all the indices and the variances. So some other aspects to take a look at this. EVM, when planning for EVM, here are the aspects that needs to be considered. Number one is the work breakdown structure that actually Jim already talked about, which actually defines the scope into low-level chunks. And then the work packages, I'm going to actually dive into by the bottom, where it's the lowest level of work breakdown structure, where the cost and durations are estimated. And then the control counts, where you actually have both the work packages and planning packages come together, and it is the basis for measuring your earned value against. Okay, so that's the basis for discussion. Okay, let's go to the next one, please. So we want to take those concepts and apply to a situation. Again, this, we're actually going to use concrete foundation as an example, but you can actually apply to piping, you can actually apply it to mechanical, or you can actually apply it where each individual bars represent different disciplines. The concepts apply across. So if we actually look at it from a schedule perspective, that tells us what needs to be done when. Okay. Now we're going to take that and turn it into a production system to talk about the how. The how of what actually goes through the system is, let's say, a concrete foundation. It's going to actually have its rebar completed on it, fixed on it, formwork completed. You'll have concrete poured. You'll actually have the form stripped, and then someone's actually going to take a look at it to say it's been accepted. Okay. Now, if you look at those operations in line with the schedule that you see on the top left, you can actually start producing a line of balance. And that actually says, here is the rate in which the work will be done. Now, take that and say any work that actually has started but has not finished, in other words, rebar has been installed but has not been accepted as your work in process. So if you actually go up the line of rebar and then until the acceptance actually comes into play, well, you end up with a bar the chart that looks like this. Okay? So that's your WIP, and that is your basis for planned value, and that's your basis for comparing your progress against it. And then say if something actually is going off the track, then we need to do something about it. Okay, let's go to the next slide, please. Now, let's look at an alternative scenario. What we want to do is actually take the line that's on the top left and compare it against the line on the top right. So by working on optimizing the handoff size that Yong actually talked about, and the sequence in which it's actually handed off, we can start to actually bring these lines closely together. Okay. Now, mind you that the black line of accept is in the same position in time-wise as the left one. You could very much actually take the whole set of lines and move it to the left if that's what you desire as a project. But the concept is actually we brought these lines together. Now, if you draw the line of balance, the working process for that actually looks like the one in the bottom right. Okay. Now, why is that actually important at all? Kristen, can you go to the next one, please? Because the area underneath those two charts equate to the amount of money that will be tied up in the system for that process. Okay. Now, in a world where a lot of investors and owners and managers are starting to actually think about how do we reduce cycle time, at the same time produce cash flow, what we might be actually thinking when we're planning for our planned value is we might be thinking that we are designing something that works, which is the left side, and comparing against it, although we're actually building more than necessary working process into our planned value. Okay, so that's something that we need to actually start thinking about. Next slide, please. So this is an example that a project has gone through. So if you actually look at the blue line as well as the purple line, that was the actual estimate at the AFE, the actual plan. Now, because of the late delivery of key equipment for this project, they had limited access to the work phases that can be opened. And therefore, as you can see, the number of people, number of labor that you actually were able, manpower that we were able to bring up was less than what they had planned. However, the project actually got done on time and under budget. Okay. Having less work open, with the less people, but getting done on time. So that's the power of WIP management that we just actually talked about using an example below, a real case. Okay, let's go to the next one, please. Now, let's actually take our mind off a little bit of the planned value, and let's actually go on to the actual cost. And again, this actually is from the standard, and what's it, in line with what Jim actually talked about. It actually says the apportioned effort and level of effort is very subjective and can give you misleading ideas. So let's actually focus on discrete efforts. And among the discrete efforts, it also actually talks about the fact that fixed formulas like percentage complete may actually give you a false sense of accomplishment, as it actually says right there. So the way it actually proposes to do things is to actually measure things that are physically complete. Again, very much in line with what actually Jim talked about. Next slide, please. Now, when we actually measure physically complete, building on what Yomo just actually talked about, is actually applying it to the operational level. We need to be very sensitive to the fact that measuring completion, even if it's physical, at an operational level may actually have very unintended consequences. Okay, so let's actually just go back to the example that we're talking about previously. And we're gonna just say we actually, not the slide, but we were thinking previously, sorry. Chris, the next slide. Okay, so right there. All right, so let's actually assume that those are the 5 activities: rebar, form, pour, strip, and accept. And each of them actually has the values actually assigned to them, schedule values, roles of credit. And those actually add up to 100% if I'm not mistaken, okay? Now, let's say someone actually is not getting a report that says we're 45% complete on our foundation, 100 foundation footings. What comes to your mind? 45% complete of the 100 foundation footings. 2 immediate ones that I can think of is we have all the rebars done for 100 footings, and we have all the formwork done for the 100 footings. So we're 45% complete of the whole scope. Or alternatively, I could actually have had 45 footings complete. Okay. Although those are the 2 same numbers, one allows the subsequent trade to come in, as Young just talked about. One, you still have a lot of ways to actually go before you can actually get the subsequent trade actually to start work. Okay. So even if we're actually measuring physical elements, even if we're actually measuring the actual quantities of work, if we try to actually aggregate it at a level using percentages, then you might actually be giving a misinformation about what the actual status of the project might be. Okay? And that's one unintended consequence, again, that we actually have to talk about. 2 scenarios that we just talked about has huge difference in what the WIP looks like: amount of cash tied up in the system, and amount of work faces open, and amount of people that you might actually need to have simultaneously to meet all the work actually that's in the open work phase. Okay, next slide, please. So not every dollar is a dollar, which means not every dollar spent actually contributes to the same dollar. I think Gary actually had the same type of discussion. He said, not all progress is good progress. I wrote that down, right? Same concept. So the question is, what do we plan? What is the basis of the plan that allows us to actually set the plan value? What is the measurement that we're going to actually use to actually accomplish the actual cost, with the mindset that we don't want to mislead incentivize people to actually take the wrong element of the progress, right? Which actually now in combined produces your earned value. Okay, so next slide. So what is the approach to these 5 elements is the key question. Again, these are the elements that is actually mentioned in the book of standards. So what we're going to do is take a look at what we would actually consider in terms of work breakdown structure, control counts, work packages, progress measurement methods, and estimate complete. Okay. Let's go to the next one, please. Specifically regarding the work breakdown structure, here's something to think about. One of the things that that a lot of projects actually try to do is to rely on a single work structure that can be broken into work breakdown structures. And then with the recent advancement of AWP and construction work packages and IWPs, what we're actually starting to see is that structure being used to actually not only measure progress, but also be used to actually manage the transportation, delivery, and instruction as to what to work on a daily basis to crew. Okay, so it actually has huge bearing on not only reporting, but also on managing work. However, depending on what role each person actually plays in a project, there is many different perspectives that they may actually have. So for example, if you're a construction manager or area manager or HSE personnel, your question is, how many people or what kind of activity is going to go in my work area or in my unit? If you are actually an engineer or specialty contractor or someone that's responsible for operations or HSE, you're saying what systems will be impacted, which may cut across many different work packages, which may actually cut across many different cost accounts. Okay? And then if you're actually going to be someone that's responsible for project controls and contract managers, you're going to be wanting to know which trades are involved, disciplines, and which companies are involved. So one of the things that we need to think about and recommend is the actual multi-structure environment. So can you go to the next slide, please? So in addition to the single work breakdown structure, we need to start using a system structure, area structure, and organizational structure concurrently to manage work so that everyone can actually look at it from the perspective they need to actually manage the work. What we tend to see in the project is start with the one structure and try to convert to another structure during the middle of a project and then convert it back to another structure. I've seen millions of dollars being spent and months and if not a year being spent and trying to convert a system area structure to a system structure and vice versa so that people can actually figure out what's going on. Okay. It's not something that's as a limitation of the technology, but it's some of the methodologies that we actually implement. So something that we need to consider. Control count should be not means of driving work, but rather than an output. So if we're actually using all these different structures to actually manage the work, and as the work gets done, control counts are a means to aggregate and report out, but not necessarily the ways to actually drive the work. Work packages, we need to make sure that they're sized and sequenced to allow integration across discipline and trade. What do we mean by that? Remember back to the 2 examples we showed in using foundation. One actually had the lines closer, and in order to achieve that, what you actually have to do is size handoff and then the sequence so that they can actually work one after the another, right? So that's what we mean. Progress measurement, again, use physical measurements, but actually focus on the completed work so that we're actually not driving a behavior where we actually a majority of the percentage completes by completing the front end operations with nothing to actually hand off to the subsequent trades. And then the last one is estimate to complete. Use the actual production rates that you're actually getting from the field to actually do so. Again, seems like a very, very logical thing to do, but we've seen many, many projects where it says the estimate to complete is the planned value minus the actual value, actual cost. right? Which means whatever's left is whatever we're going to spend to actually get the project done. It makes the end target, the forecast actually look good, but a lot of times that actually becomes very unrealistic forecast. Okay. Okay. Next one. Okay. And we're going to then hand off to Gary for any questions.
Sitting here, chewing on what you just presented, a lot of good food for thought. Just real quickly, can you explain a little bit more about what a control account is? We got a question on that.
Well, let's actually go back to the previous slide where it talks about the control counts. Can you go back up a few more? Again, I think it's something that's a few more right there. No, actually, one more, please. Keep going back up. Keep going up. One more. There you go. Yeah. So control count is this is actually straight up from the standard a management control point where scope, budget, actual cost, and schedule are integrated and compared to EV for performance measurement. A control count has work and planning packages. So if you actually look at the diagram on the right, it actually states that the project budget is broken down into performance measurements baseline, which is the integration of all those scope, budget, and actual cost and schedule. And from there, it's actually broken into multiple cost accounts, where each one actually might have your different work packages and planning packages. So that's the PMI's definition of cost accounts.
Okay. So we got a question here. While minimizing WIP is an intuitive goal, one must account for the fact that the inputs to the work, labor, material, information is not infinitely flexible or able to be turned on and off. How do these constraints get factored into the WIP calculation and forecasting of what to do next?
Okay. Okay, do you want me to take a run at that?
Yeah.
Okay. Yeah, so again, the mere fact that the labor and the equipment and information is not flexible is the reason to actually focus on WIP, right? Because if those are actually not flexible, that means you actually have limited expansion on capacity, the ability to do the work. And if the WIP goes beyond what the capacity is able to handle, you're now going to be seeing more work queued up, i.e. WIP increase. So in order to prevent that, you would definitely want to actually control amount of WIP that's going into the system. Okay, so that's why we actually talk about it. Now, how we actually figure that out of how much WIP actually needs to be done is something that I think would actually go beyond the timing allowed for this webinar. But there's a lot of good information on the project production management website. It actually talks about the WIP as the leading indicator of cycle time and how you actually set that WIP target and how you can actually control to it.
Very good. So Young, you got how value is created. It has me thinking. Or did you want to add something on that?
Yeah. Actually, I want to add something on to the previous question.
Sure.
Because here probably the WIP is as maybe we use all the panelists use the example of the unintended consequence of the on-value method. Probably another issue that we should see is some hidden waste that we don't see usually. For example, in my examples, like a trade 2, suppose the scenario trade 1 and trade 2, and trade 2 expected to receive some certain task. So I maybe trade 2 arrange the resources, expecting to receive the task in the plan, weekly work plan or something like that. But the trade 1 worked first on the high budgeted task and released them first unexpectedly. Then what happened is the resources that trade 2 arranged is not used. Actually, they are usually not found in our site, right? So that is kind of additional the waste that is hidden. So that might be more important than the WIP that you can see on the site.
Yeah. Good point. So let me ask you another question. You're drilling in on when is value created, because that's very That's very insightful. So are we saying that perhaps projects should not even count progress that wasn't planned?
No, actually, so that is actually that put the stress on the importance of the production system design. So when you develop the schedule or planning, you are developing production system. So when you develop the system, you should consider the value. Value should be assessed in two different terms, like timing and also quality and quantity and all the hands-on. So those hands-off and timing should be fully discussed with all the relevant stakeholders and trade in the planning session, not in the execution session. So value should be fully defined clearly and acknowledged by all the relevant stakeholders in the planning. Yes, that's my answer.
So we got a good question here, is it feasible to construct via systems, or do we have to switch to areas to construct? Who wants to grab that one? Jim, you want to take a shot at that?
Sure, Gary, absolutely. Absolutely, it's feasible to construct via systems, and we often tend to get involved in projects in a recovery sense, right? And when we come into a recovery situation, we are 100% focused on system turnover, according to the critical path, to actually have a product come out the door at some feasible point in time. Yeah. Because that's another kind of value, right? That the revenue value of the project. So in that sense, we always focus on system progress and turnover in a rational way that allows for completion and actual operation of the facility.
Yeah, my experience has been that systems were a little bit of an afterthought. And I think James pointed out the importance of getting the structure of the work breakdown structure thought through sufficiently at the beginning, so all the different needs of the different customers could be met. As too often, and James, you can chime in here, but too often I've seen that systems were identified very late in the process. They weren't on the P&IDs, they weren't in all the information, and so then trying to understand where you were on a system basis was nearly impossible. And it just required going down and walking down each system to find out what was there and what wasn't there.
Yeah, I mean, constructing by actually system is possible, right? But as we actually just talked about previously, it's the reliant on a single system through a phase, right? So when we actually we do engineering, people actually tend to look at engineering as something that's done by systems. And then people actually tend to look at construction, and especially the bulk construction, is something that's actually done by area. Mm-hmm. And then we say, oh, now we're actually moving into the completion period. We got to now systemize. But if you actually think back, the original thinking of the project was system-based, right? So it's something that what we actually have to do is to have the ability to manage the multidimensional work breakdown structure, if you would, throughout the phase, so that it's not dependent on a single structure that we actually have to convert, but it's a structure that we actually keep defining as we go through the project simultaneously. But it's something that, a lot of the legacy thinking and methods and technology that we deploy today is forcing us into thinking into like a one structure view.
Yeah, right? Which is a big issue, and that's the point you're trying to make. Yeah. So one of the things that I heard prop up in the last 5 years was progressible and non-progressible work. Anybody want to tackle that one? What the heck is non-progressible work, and what's the implications of that? Jim, got a big smile on your face there, buddy.
I was going to let James handle this one because I could see him laughing, but progressible, non-progressible, right? So, as we discussed, we oftentimes come in the middle of these projects and have to do root cause analysis of why things go off track, right? And it's during that root cause analysis that you discover the non-progressible work. And it really is getting back to the fact that predecessor activities or predecessor equipment or predecessor designs have not been completed in such a manner that it allows us to physically progress a critical piece of work that we need to have done so that we can actually turn over a system on the critical path to get the plant operational, right? So that's how we think about non-progressible work, but we take it one level deeper, which is what is it the actual root cause of that, and how are we going to, change the outcome, right? What do we physically have to do to change that outcome?
When I heard that terminology pop up on a project, it sounded like cancer to me. And stomp it out and eradicate it as quickly as possible, because all non-progressible work still needs to get done. Well, I'm sorry, we're going to have to cut off the questions here to do our wrap up. Got a lot of good questions here we weren't able to get to, but it looks like you stimulated a lot of good interest. I want to come back to kind of put a bow on what we've heard here and tack back to the reasons I said EVM even exists, what the owner needs to be able to understand these things, and then the reality of those. So understand current status of the project, physical progress, cost and schedule. EVM overstates beneficial progress and drives excessive work in process. Are we able to predict cost and schedule outcomes? Well, cost on a gross basis, yeah, it doesn't do too bad, but schedule is not good at all. Able to compensate contractors, synchronize with progress, yeah. But that linkage really needs some rethinking, because it drives, I'd say, game playing, and it distorts what beneficial progress is. Just like was pointed out on doing things that have high credit, which usually means high dollars and early payment. So they got to tread with extreme caution. I personally would not link the two. Find another commercial solution for payment of contractors. And then take corrective action if the project is off track. I don't think it works at all. In fact, the typical response when a project is behind schedule is, we got to re-baseline. We need to add resources, right? The end date never changes. Just the hockey curve gets plotted in there. So taking all that in mind, James had some really good recommendations. Go to the next slide. I'm not going to repeat all those right here, but the next slide. There we go. I want to ask you to think about his recommendations, think about your project, and ask yourself these questions relative to what he just said. What's your approach to how you generated a work breakdown structure? What are your control accounts, work packages, progress measurement method, estimate to complete? And I know we may have left you just a little bit wanting a little bit more on, it's okay, what do I do? If you go to the next slide, we're about ready to publish a paper which has a lot more detail in it. I think you're going to find this very informative and very helpful on structuring your progress assessment system to give you meaningful information without all the unintended consequences of EVM. So just a quick shameless advertisement. Once again, if you're new to this and you haven't caught the prior webinars, we have several of them. We'll just troll through the slides here real quickly. Just a reminder. And look for our advertisement for the next webinar to deal with stage gates. I think that's going to be even more interesting. So thank you, our panelists, for taking the time to participate today. Appreciate the time and energy. And thank you all for tuning in. Goodbye.
Thank you, Gary.
Thank you. Thank you, Gary.
Thank you all.
Good job, guys.